we are already able to jump, and our camera is now following our player node. So the next thing we want to do is add the possibility to spawn new lanes as we move forward, so that our player doesn't ever reach the end of our map. This way we want to achieve the infinite feel of the original Crossy Road game. As of now, we have in our setup scene method added 20 lanes to begin our game with. Using this for loop, we decided whether it should be a grass or a road lane, initialized it, positioned it, and then incremented our lane count. We've also added the lane to our lanes array, and finally added the lane as a child to our map node. All of this is what we need to do when we now want to spawn new lanes, which is why I want to take all the code from within the for loop and create a new method that will contain it. So I'll add a new method right at the bottom of my class called createNewLane without any parameters or return values. And I will then use this method whenever I want to add a new lane. I can then just cut this code from my for loop and instead just call the createNewLane method, inside of which I will then paste the code for initializing and adding a new lane. As we can see with the underscore counter in our for loop, we do not actually need any information provided by the for loop for the initialization, since we will use our lane count property to position our lanes properly. We can now also use this createNewLane method in any other place. We might want to add a new lane to our game too. I'll create a new method right above createNewLane, which I will call addLanes. I do want to add 2 new lanes to my game anytime our player jumps forward. Why 2? Since our camera is at an angle, we can actually see a little further than just 1 lane, so this just makes sense to add 2 lanes to make sure that we never actually see the end of our map. To achieve this, I will create another for loop with for_in 0 up to 1, so exactly 2 iterations, and then call createNewLane inside of the for loop, which will spawn 2 new lanes. The process is exactly the same, like for our other lanes. We generate a random type for a new lane node, position it according to the current value of lane count, and add it to our scene. And that's pretty much all we need to do. We now have to call this addLanes method in the appropriate place, and that is our jump forward method, which gets called whenever our player should jump forward. Inside of the if-let statement, so when our player actually jumps, I can then add the call to add lanes, which will add the 2 new lanes to my map. I will then run the application to see if this works and we spawn new lanes. We shouldn't be able to reach the end of our map this way, but just to be sure, let's take a look. As the app starts, I'll just keep jumping forward to see if I reach the end. It appears that we can't actually reach the end of our map, and our new spawn mechanism is doing its job pretty well. Perfect. We now have an infinite game that should theoretically never end. There is a slight problem though, so let's take care of it. We are able to infinitely jump forward and spawn new lanes, which is pretty good. However, this does increase our total node count with every jump, since even though we don't really need the lanes that we already crossed, we still keep them, and they don't get deleted nor removed from our scene. Now, if we keep moving forward for a while, this might lead up to problems with our memory and ultimately the performance of our app, because we just keep everything in the game and not delete anything. It's important, like in most games, that we not only take care of spawning new elements, but also dispose old elements that we don't need anymore, like the lanes we already crossed, for example. To do so, I will, below the addLanes method, create a new method called removeUnused_lanes. And I want to call this method each time we call our addLanes method, since We then jump forward, and one or more lanes are possibly no longer in our camera view. So let's just call it at the bottom of add lanes in the remove unused lanes method. We now have to think about how we can access the nodes no longer visible in our scene and how we can remove them. We do know that all of our lane nodes are child nodes of the map node property, since we've added them this way in the create new lane method. So to access all lane nodes, I can begin by writing for child in map node dot child nodes, which will give me each child node of our map node property. I now want to remove those nodes that aren't in the view of our camera node anymore, because they simply moved out of the screen at the bottom. Lucky for us, there's a very convenient method in SceneKit that allows us to check this. So I'll just write if !sceneView.isNode and then select this method with the node and inside frustum of parameters. And I will just pass child as the node, and for the second parameter I'll say camera node. But what does this method do? It checks whether or not a passed node is inside of the view of another node. In our case, this would be the camera, obviously. If we then use the exclamation mark, we can easily check for nodes that aren't visible in our camera's view and therefore the area that we can see as the user of the app. There is something challenging about this though, because some of the lanes that are spawned can also be outside of the view at the top of our screen, and we certainly don't want to remove those, since they will become visible once we move forward long enough. So I will add a logical AND operator to also check if child.worldPosition.z is bigger than playerNode.worldPosition.z, which would mean that the node is not visible in the camera and also behind our player node from our point of view. And those are the nodes that we actually want to remove from our game. World position is just used to get the absolute position of the nodes in our scene. Therefore, I will, inside of the if statement, write child.remove from parent node to remove the node from my scene and free the memory. And I will also write lanes.remove first to remove the node from our lanes array, since the lanes that are moving out of our scene are the ones at the beginning of our array. We can just use this remove first method to conveniently do this. Our remove unused lanes method should now make sure that our app doesn't keep our unused nodes in memory forever and deletes them as soon as it is possible. Let's maybe add a print statement that just outputs removed unused lanes to the console each time our method runs. I will then run the app again, but we shouldn't see any difference. We should still be able to move forward indefinitely, but we should get the output in our console whenever lanes are removed from our scene. So I'll just jump forward a bit. Like I said, nothing really changed within the app, but if I now take a look at my console, I can see that there are a bunch of print statements telling me that an unused lane was removed. Even though we didn't run our app that long, we can already see that there are quite a lot of lanes being removed. And this just shows the importance of removing unused nodes, which should greatly improve the performance of our game in the long run. We will now continue by adding more models to our game, and we will start by adding some trees and hedges to our grass lanes, which should make them look a bit more appealing. We will then advance to adding vehicles to our road lanes to actually have some obstacles in the game.